Our second calculus video using differentiation to work out values. Last time we said we'd come back to question 6 on page 2 of your notes, where the question says there is a function f of x equals 3x squared. Find the gradient when x equals 4. Steps are very simple. First step is not to substitute in the value. First step is always differentiate first. We differentiate if it says work out the gradient, work out the derivative, just tells us to differentiate, says find the rate of change, anything like this, differentiate first. So we start off in our answer, we write down the function given, f of x is 3x squared. Find the derivative, f dashed x, multiply by the power, take 1 away from the power, 6x to the power of 1. That's f dashed x. That works for any point x on the curve or in the function. So I'm now going to plug in the value they tell us, x equals 4. So we'll say, therefore, f dashed 4, just substitute in 4 instead of the x. So that's 6 multiplied by 4 equals 24. And that's it done. Differentiate first, then substitute in the particular value they tell us. This one's more obviously a graph. It doesn't state it as a function. So we're adding in a question 10 on the questions we did on page 2. Here's a graph. Y coordinate equals 4 root x, take away 7. Calculate the gradient of the curve when x equals 9. Step 1 we said is differentiate, but it's not in a form where I'm allowed to differentiate. Remember, we're not allowed to differentiate if the x term is underneath or if it's got a root on it. So let's get it into form we can differentiate. Y equals 4 root x, that's 4x to the power of a half. Take away 7. I'm not going to, even when I get something like this, say, oh, this part of it I can differentiate. I know how to differentiate 7. Don't do anything until you can differentiate the whole thing. So write it in a form we can differentiate, then we'll differentiate each part. Because the question said y equals, I'm not going to write f dashed x because there's no f of x up here. So since we're talking about y equals, and also, to be honest, since we're talking about gradient at any instant, because it's a curve, so I'll write dy by dx, but that just means differentiate. I said that the whole differentiation thing was completed really 300 years ago by two different mathematician cum scientists, Newton in Britain, who used the f of x notation and was working with functions in his notes, and at the same time in Germany, Leibniz was using it and relating it to graphs. Descartes at the time had just come up with Cartesian coordinates, and lots of mathematicians are doing work at the time, and so Leibniz was talking particularly about graphs and gradients and areas. So if we've got y equals, we will write dy by dx equals. It's known as the Leibniz notation since he came up with it first. Anyway, we have a form we can differentiate. Now that we've got to here, multiply by the power. 4 times a half is, of course, 2. X to the negative a half. That's the half take away 1. Differentiate a constant number, 7. Well, that's 7x to the 0. 0 times anything. If I multiply by the power, well, that bit disappears. Remember, a constant number disappears. That makes sense. If I had a graph that just said y equals negative 7, remember that's a horizontal line. The gradient would be 0. So a constant number, the gradient is 0 always. All right, I now want to plug in my value x equals 9, but if I put this in 2 times 9 to the negative a half, okay, I don't like this negative power and how I'm going to deal with that. So let's get it in a form where I can substitute the 9 in and work out the value easily first. So before I substitute in, I'm going to write this in a form where I know I can work out the answer. So I'm going to say that's to get rid of the negative sign. So that'll be 2 over x to the half. Oh, but that equals, my gradient equals 2 x to the half, I know means root, square root of x. Now I can substitute in any value I want and hopefully can work it out. So I'm going to say, in this instance, dy by dx will be 2 over square root 9. For when the question says work out when x is 9. Oh, that's 2 over 3. My gradient is 2/3. And remember we said before, differentiation is the 6th way that we can work out gradient. On page 4, a further example. Talks about a roller coaster. It says the distance and the formula is d of t equals 10t squared, take away 3t. It says that's the formula for distance, d meters, and work out the speed after 5 seconds. We don't have f of x, we have d of t, but there's nothing magical about the letters f and x. Rate of change, speed is just rate of change, so it's a rate of change question. That means differentiate first. So on page 4, our example there, we start with the formula. And it's not got f of x, it's got d, so I'm going to say my derivative is d dashed t, just the same thing as saying f dashed x. I'm going to differentiate, multiply by the power, take 1 away, so 10 times 2, 20, t to the power of 1. Take away, this is t to the power of 1, multiply by 1, take 1 away, take away 3, t to the 0, well that just disappears. So my derivative, d dash t this time, 20t take away 3. The question says, what is the speed, which is my d dash t, my rate of change after 5 seconds? So if we use t for time, I'm going to substitute 5 in there. d dashed 5, be 20 lots of 5, take away 3, 20 times 5 is 100, take away 3, 97. And because I know what the question is talking about, I can actually, as well as value, put in some units. We're talking about meters per second. Depending on your physics knowledge, you might write m/s or ms to the -1, meters per second either way.